the rest of this chapter now is starting to apply some of these sort of fundamental characteristics to bigger things. In a lot of ways, this is actually easier because we can measure and manipulate these things pretty quickly. And the formulas are actually quite simple too, because we've got things like Ohm's law, V equals I times R. That's what we're going to be doing today, is applying Ohm's law, seeing how it's applied to circuits. We're going to be doing this with a series circuit. Series means when we connect these things, all of the different components will be connected in a single path, so that there won't be any branches. It will be quite simple. I've asked in the lab that you start out with the simplest circuit, which would just be your power supply connected via wire to, what's this? Anyone remember? Resistor. The resistors will have put out, you can use different resistors, but don't start too low. So start with like a 10 ohm or so. And then if you want later on to have a very small one, like a 1 ohm, that's fine. Any of them in these are okay. Although I would still probably keep it to 150 ohms or smaller, just because when you go to larger resistances, the measurements get much, much smaller and your precision counts that much more. Yes, sir.
What would happen if you just brought the wire around?
Well, you tell me, what would happen?
No idea. Just do nothing.
We did Ohm's law, right? This voltage you'd set to, I don't know, 5 amps or 5 volts or so, let's say. What would resistance be in just a wire? Not zero. Near zero, though. We learned about, with the Play-Doh, about that, and a metal wire, especially these are all copper, has a resistance very close to zero. So if this is 5 volts, and this is nearly zero, what's the current? 0, because 0 times 0 is 5?
It's really, really big.
It must be really, really big. So that would be a problem for us. That would be called a short circuit. It's a pathway that allows electrons to flow extremely easily, and we want to avoid that because it can damage the equipment. 5 volts, look at Ohm's law. You are on the order of maybe 10,000 ohms. 5 volts isn't going to do much to you. Right? It's not a dangerous voltage for us. Even 12-volt car batteries, although they scare you, 12 volts isn't very much. So unless you're up there licking your fingers and touching the sides, it's not going to hurt you. It is scary when you accidentally make them spark. But it's not a high enough voltage to really hurt you.
That's what it is on
I don't know. Well, when you were playing back on the Van de Graaff generator, or when you go across a room and touch somebody after and you get a zap like that, that could be 20,000 volts. Voltage is unimportant. That's the one that hurts. Yeah. I forget whether it's 1/10 of an amp, or I want to say just maybe a few hundredths of an amp. In the right spot is enough to stop your heart. It's in the book. It's in your reading. So I'm sure you've come across it, so just look through that. For us, what we want to do is I want you to measure a couple different things in this. I want you to measure what I've got is the battery voltage. Really, that can be our power supply that we've got. So just measure that. Not time for questions right now. I want you to measure the voltage across any and all resistors and keep them separate. You notice that you've got a slot for each one. And I also want you to measure the current going through this. Now, the nice thing about current is if an electron exits the negative side, it's got to go through the whole circuit, every single part, at the same rate in order to get to this other side. It's not going to be going faster in some areas and slower in others. It's got to keep flowing at the same rate. So you could put the multimeter set up for measuring current anywhere you want. Just remember that, and I can come check stuff, but remember that this is it goes in place of a connection or a wire, and so electrons have to go through it and then onto other parts. Never ever put an ammeter like this because this is like a wire. It's like a low resistance. This is another one of those short circuits. The electrons would just get here. They'd be able to bypass that resistor. And so they'd flow very, very quickly through that part of the circuit, overheat, possibly cause damage to equipment. The second one, I want you to add a resistor. So keep that one in. Add a second resistor. You can keep the current measurement where it is, but now you're going to be measuring the voltage across 2 resistors. And add a third one and so forth. So you'll need a fair number of alligator clips for this and 5 total resistors. We probably still have plenty of time to set all that up and make all the measurements. And then go through that. And when we get in back, there are a couple of questions to sort of lead you to there are 3 important rules, one about each V, I, and R about series circuits that we want to know and apply. Yeah?
Will we just measure one resistor if we're finding the voltage if there's 2? And then like...
Each and every one. That's why, so there, if you look on your lab sheet, there are, if you have 2 resistors, there are 2 places for voltage. Yeah.
So they have separate voltages?
Well, you're going to find out. You're going to measure each and every one. I'm not going to tell you what you're going to find now. That's the whole fun of the lab. Okay, so let's go back. As there are questions getting set up, we can answer those as well. The power supplies are still in back, but you'll need to get some of the other materials up here.
No, I was going to ask a question.